All right. So everyone sees the
Yep.
quiz here? Okay, good.
Mhm.
All right. I guess I can start
I
us here.
cannot hear them.
You can't hear me?
Gabriela, do you hear me?
I can hear you now.
I can hear her
I
too.
cannot hear you now.
Anybody able to?
I shouldn't be.
Gabriella, we're still hearing each other, right?
Yes.
Hmm.
She's a little cutting off in and out.
I cannot hear you guys. I will try to do something here. I cannot hear you.
You cannot hear me? Hello?
Oh, you can hear me?
I can hear you.
I don't know what.
Can you hear me?
Should I, I don't know. Should I go and enter again?
Yes. Let's see if it is will be a better reception.
Okay.
Oh.
I'm here.
Oh, you're here. Okay. My
I just
screen
figured,
said you were no longer present.
yeah, I'm not sharing my screen. It would just show that infinite, screen within a screen shot.
Yes. Yeah. Okay, let's see.
Okay, here I am again. Can you hear me?
Yes, I can hear you. Can you hear me?
I cannot hear you now.
You cannot hear me? Are
Oh, I don't know
you in a
what's
different
happening.
computer?
Mm, because at the beginning I could hear you.
I can hear you.
Mm, mm.
Hello?
Yes.
I can hear you.
Mm.
Gabriella, are you
I don't
getting
know
the
what's
text?
happening.
What's that?
Are you receiving the text in the group chat?
No.
Well, she is, so we can try to text her.
Okay.
Um, let's see if I can figure this out. Because I want to share my screen, but I don't want her to see anything but the chat. Well, let's try that. I'm already broadcasting, so
All right.
let's share this screen again.
Okay, if I get out of here and I look at the what is it? the text. I won't.
Yeah, let's. I'm going to ask her if she can. I wouldn't worry about you doing it, but I'm wondering if she can do both. So I'm going to ask her. She's gone and coming back.
Okay.
It's got a lot of background noise.
Oh, yes.
I'm going to stop presenting or sharing screen.
Okay. I wonder if she's at work.
She might be.
Looked like she was somewhere else instead of home.
Yeah. I unfortunately have to do this at work too because there were no evening slots after 7 that were open. So
yeah, my evenings are terrible.
I'm here. Can you hear me?
Yes.
Okay, I can hear you now.
Oh, yeah. That's great.
I was really worried about that.
Awesome.
Thank you for waiting for me.
No problem. Is everybody seeing my screens or my screen? Okay.
Yes.
All right. Bear with me just a second here.
Sure.
Okay. So use the normal probability applet to find the combined area under the standard normal curve that is to the right of z 1.358 and the left of z minus 1.358. So what we want to do here on the applet is put 1.358. We want the left and the right side. So that gives us an answer of 0.1745. I don't know if you can read that, but that's what it reads right there in the area.
Yeah.
Okay.
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 Yes.
I'll read it. Which of the following will have a smaller standard deviation of 9 observations around population? So the distribution of the individual observation is simple. What is it called? Is it called simple? Yeah. The distribution of the sample means this cannot be determined from the information given. I think is the distribution of the sample means.
I agree.
Sure.
Because this number is divided by this number is this number divided by another number.
Right.
So that should be smaller. Yeah.
I didn't get it. Sorry. Can you please explain again?
Oh, sure. Let me take it up here. Gabriella, do you want to, or you want me to do it?
Oh, go ahead. You explain it really good.
So we know that when you're doing a standard deviation, that you can well, you know that when you're doing a standard deviation of the distribution of the sample means, that the formula is the standard deviation divided by the square root of how many samples you have, or 9. So
Okay.
when you do the distribution of the sample means, you're taking this number here that would be found in answer A and dividing it by the square root of 9. And so anything you would divide by should be a smaller number. So that's how we got that.
Okay. Thank you. Thank you. I got it. Thank you. Okay. Oh, which of the following results implies that the spread in media mean decreases as the sample size increases? Okay. Mhm. It says it is central limit theorem. Right, because it says because it's not the normal distribution. It's not the rule. Because as it says, right, the mean decreases as the sample size increases. I think it is the central limit theorem.
Well, remember
No.
this. Remember that the central limit theorem and the law of large numbers are very, very similar, right? The central limit theorem should mean that that a sample becomes more normal. So it's about shape.
Yeah, size and shape,
But the law of large
Mm.
numbers is about accuracy.
accuracy.
So
Yes.
when the mean decreases, that makes it more accurate. That's why I
Oh,
believe it's the law
Yeah,
of large numbers.
I agree on that. I think it's that
yeah.
of large numbers.
The law of large number. Okay, sorry. Thank you. Okay.
It's back to me, right?
Yes.
Yeah.
And we're on 6 here. It says Diane earned a score of 160 in the quantitative portion of the GRE. What is the Z corresponding to Diana's score? Round your answer to 3 decimal places. So that should be
So we're using the Z-score formula, right? In this one.
right. Correct.
Okay.
So that should just be
Okay.
160, right? Our score
Yeah. Yes.
minus 150.8,
150.8.
and then divided by the standard deviation of
8 point.
Mm-hmm.
8.8. So 1.045.
To 3 decimals. Okay. Okay. What is the probability that a randomly selected student will score 160 above 160 on the quantity portion of the GR? Oh, GRE. I'm sorry. So, and then we have jury. Uh, and we have to use the 150 still for this one.
Well, I think it's so in number 6, we figured out what the Z score was for 160.
Right.
And then it says above 160, what's the odds of that? And so we should be able to use the probability applet here
Oh, with the same. Okay.
because that score was already known, right?
Oh, yeah. Yeah, that's
Okay.
right.
So what am I inputting here?
So you're putting 1.045.
Okay.
What am I doing to the applet?
And the left side, oh yeah, okay. So, so 0.148 is the answer.
Okay. What is the score corresponding to the sample mean of these students' scores? Okay. We need to find the mean first, right?
Correct.
So
Yes.
we add the numbers. Okay, I'm doing that. Divided by, okay, I got 160. Okay, now that we got the mean, we use the formula that we just learned, right?
Yeah.
We, okay, 160 minus 100, minus what? Minus, okay, we have, oh, we have the mean that is
One.
150.8, right?
Right.
Now we divide this by, um, we have the standard deviation 8.8
Right.
divided, oh, let me see. Yes, divided the square root. You said, no, how do you say that symbol? The,
Yes, right here's the symbol.
yes, what is the name?
Square root.
Yes, square root.
Mhm.
Uh, of 5. Do you agree? Oh, of, uh, because, 1, 3, 4, 5. We have 5 numbers. So, I thought it was the square root of 5. Am I okay? No. Am I correct?
Yeah.
Let me check.
1, 2,
Okay.
3, 5.
I
Yeah.
was okay. I will do it in my calculator. 8.5 divided by 0.5. Oh, how much more? Okay. Oh, minus divided 8.5. Oh, sorry. Let me just do the math in my calculator. Divided. mm, I got 2.3377. Yes, I got it.
Yep. I was going to write it out here to make sure we were on the same page, but that's the right answer.
Okay.
Okay, thank you.
Oh, you got 7, 7. I don't know why I got 8.
It's rounding up to 8, which is what we
Okay.
should do.
All
So
right.
Oh,
2.33.
338. Okay. Sometimes the calculator does the approximation, right? Okay, I got it. Thank you.
Okay, is it back to me?
Yes.
Okay.
Okay. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So that score is 2.338.
Oh,
What? What is the probability that farmers will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay. So the answer should be 0.009. How many
97.
decimal points? 4? 0097.
Yes, 4.
Okay.
Oops.
Oh, you have 2. Yeah. There you go.
Okay.
Okay.
Okay. Use the following information to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. There's well known that this distribution is left skewed. A random
Let's
sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable sample, which represents the sample mean of the 81 students who are selected? So, okay, this left skew.
I think the important part here is the sample size.
Oh, okay, yeah.
oh,
So if it's over 30,
which represents yeah, approximately normal. Mm-hmm.
okay.
Well,
I
thank you.
agree. Okay. What is the mean of the distribution of the sample mean sampling distribution for all possible samples of size 85 that could 81 that could be drawn from the parent population? Okay.
What is the mean?
What is the mean? 3.5. It is
Yeah, yeah.
3.5. Yes, the mean is 3. Oh, we have to use a formula here.
yeah.
Oh, okay. So, mm, formula. Okay, and it's the same formula, right?
Well,
Uh,
what is it asking? Is it asking just the mean?
Yeah.
I thought
Yeah,
just the mean.
you don't need a
It
formula.
would
It's
just
asking.
3.5, right?
Yep.
Yeah, it's just
Okay,
3.5.
thank you.
Okay, 12. What is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So, standard deviation of the distribution of the sample means. So it's, so we know what the standard deviation was. Wasn't that 0.07?
Yes.
Yes,
0.7.
0.
Yes.
0.7 divided by The standard deviation is 81, but we have to get the square root of that, which is 9. So divide by 9,
Square root.
and that would be 0.0. And yeah, I didn't use the formula because 9 times 9 is 81, right? So it's 0.078.
So what did you do? You said 9.9 times 81?
Well, the square root of 81, square root, just what number times itself.
Oh, okay. I see.
Right?
Yeah.
So 9 times 9 equals 81. So the square root of 81 is 9. So it was the formula for that is 0.07 divided by the square root of 81, which is 9, or 0.7 divided by 9, and that equaled 0.078.
Okay.
Okay.
Okay. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So okay.
We don't have.
We're looking for the probability. What is the probability? So I'm gonna use that formula. 81 with less than 3.3. Okay. Let me. Okay. I got 0.005. How many 3 decimals?
I think we have to use the applet for this, though.
All right.
And what's the z-score for?
The z-score.
Right, isn't that what we need to figure out is the z-score for 3.3 and put it in here?
All right. Equals. All right. So okay, how did I do this? Totally lost here. Sorry.
If we start out, right, if we have 3.3 is what we're trying to find the z-score for, right? And was the mean 3.5?
Yes.
Yes. 3.5.
Okay, so 3.3 minus 3.5. So negative 0.2. Let's save that to memory. And then let's clear this because the bottom number, right, is the standard deviation divided by that number. So it's, isn't that point, was it 0.7 or 07? 0.7, I believe,
0.7?
divided by
Yes.
9
Yeah.
equals 0.078. So let's put that in memory save. Well, let's clear that. And so isn't the formula supposed to be this divided by this
Yes.
equals? That's not right.
I got minus 2.5714, but I'm not sure. I will do it again.
2.5.
2.5714.
I think it's 2.564 is what I'm getting. Doing it on the screen is messing up,
Okay.
but it should be 0.2 minus divided by 0.078. Yeah, so that's 2.564. Does that make sense?
Okay, let me, okay. I will do it again. Sorry, just wait me for a second, please. I don't know. Oh, okay. Maybe because now you are taking the all the numbers, right? Maybe I approximated before getting that. I got it. Thank you.
Okay. So I'm sorry, I took over this problem. I didn't mean to.
No, it's okay. I really didn't know where I was going with this, so it's okay. Thank you so much.
So I think, and it says, so we know this z-score is 2.564, and then
Right.
was a probability select this to be less than 3.3. So it should be that's wrong.
Maybe just we have to shade just the left, just the left
yeah,
part.
yeah, that's right. 0.05. Yeah, that's right.
That,
Thank
okay.
you.
5.2.
Thank you.
Sure.
Everybody agree with that?
Yeah.
Yes, I agree with that. Thank you.
Thank you.
Okay. What is the probability that the mean GPA for 85 randomly selected BYU Idaho students will be greater than 3.3? In that case, am I all right doing 1 minus 0.0052?
Yep.
Okay. 0.995. Thank you.
I think I have to put 0 on this, or we'd get it wrong.
Okay.
Yeah.
Let's see if I did that to any of the others.
No, I think put all the zeros in there.
I just had missed that one.
Yeah.
Okay. All right. I think this is back to me. So
Okay.
the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of random sample 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample passengers will have a weight that is extreme or more extreme than the other. So let's just find the z-score first. And I think when it says extreme, or it would be the ones on the left and right. So you know what?
We need to shade those then.
Yeah, you know what? Let me type this in on the other screen here.
Thank you.
Then I'll bring it over. I think there's a better calculator here. Here we go. Okay. Yeah, there we go. Let's do this. So that's the formula that we got, right? That it ours is 177.6 pounds. The mean is 185. So the formula is that minus that, whatever that figure is, over 26.7, which is the standard deviation, divided by the square root of 48, because that's how many samples they had.
Mm-hmm.
Right? So that means 1.92 is our z-score. Let's pull that back up here. It's 1.92. And then what does it say? It's extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the means as ours in the positive direction. So that should be both
Yeah.
left and right.
Extreme.
So that answer should be 0.055.
5.
Yes, I agree.
What did I do this time?
Oh, it's the minus.
Okay, should we try this?
Yes.
Okay.
Yay.
Ah, yes.
Awesome.
Thank you.
No, thank you so much.
Thank you very much.
I think that's good. And stop screen sharing. I think that's it. I'll post this tonight.
All right, great. Thank you so much for your help, and appreciate it.
No problem. See you next week.
I appreciate your help. I'm a little lost, but I'm trying to do my best. But
Yeah.
I feel
If we need
very
to slow down on any of them, let me know.
okay. Okay, today it was okay. I need to. I don't know, but it was okay. Thank you. I appreciate your patience, your help.
No
Thank you
problem.
very much.
Yeah,
All
both of
right.
you. Thank you so much. I have
All
to
right.
study more now.
Talk to you.
Thank you.
Talk to
Bye
you Tuesday.
bye. Bye
Bye.
bye.